Alright, part 2 for integration by parts, and this time we're going to get a little bit funky, so stay with me. The two examples that I'm going to do with you here, we're actually going to need to do integration by parts twice in order to successfully find the antiderivative of these wicked cool functions. So here we have 3x squared minus x plus 1 times sine of x dx. Should be able to clearly see that there are two parts here. And the polynomial is what we're going to let u be. So u is equal to 3x squared minus x plus 1. And I'm going to use a slightly different notation than I did in part 1. Instead of calling it v prime, I'll call it dv. Some of you might take to this a little better than you did v prime. Doesn't matter. Pick whichever one you like. This video, both these examples, I'm going to use dv and du instead of v prime and u prime. So dv is going to be sine x dx. That makes v equal to negative cosine x. And du is 6x minus 1 dx. So integration by parts tells me that I can now write this as 3x squared minus x plus 1 times negative cosine x minus the integral of 6x minus 1 times negative cosine x dx. Whew! And I'm going to clean this up just a titch before I do anything else. We have negative 3x squared minus x plus 1 cosine x plus the integral 6x minus 1 cosine x dx. And I hope that you see that this structure that we're left with now is very similar to the integral I started with, except now the polynomial is depressed 1 degree. Now we have a linear polynomial, and we can use integration by parts again, and that's going to get this differential here down to just a constant. And I already used u and v. I'm going to switch up my letters. I'm going to use r and t. So r is equal to 6x minus 1. dt would be equal to cosine x dx. dr is 6 dx. T is sine of x. And here we go again. So we still have this original piece. And then we're adding this integration by parts piece again. So we're doing r times t, 6x minus 1 sine x minus the integral of t dr. So 6 sine x dx. And now this final integral that I have, 6 sine x, that's something I can just find the antiderivative of. The antiderivative of sine is negative cosine, and I'm practically home free. So we have negative 3x squared minus x plus 1 cosine x plus 6x minus 1 times sine of x. And then it becomes plus, because the antiderivative of sine is negative cosine, 6 cosine x plus c. And there, ladies and gentlemen, is our antiderivative of 3x squared minus x plus 1 sine of x dx. And to get there, we had to use integration by parts, not once, but twice. So here we go. E to the x cosine x dx. This one, ladies and gentlemen, this one is even awesomer, more wicked than the one that we just got done with. So what are we going to do? Well, I'm going to let u, the e to the x, and dv be cosine x dx. That means du is e to the x dx. D is sine of x. Okay, so we have e to the x sine x minus the integral of e to the x sine x dx. And you can see that the structure of this integral is similar to what we started with, so we need to use another integration by parts. So I'll let r be e to the x and dt be sine x dx. And if you're doing integration by parts a second time, you should really stick to the same kind of structure that you used for u and dv the second time through. So I'm letting my r be e to the x just like I let u be e to the x in the first step. dr is e to the x dx. T will be negative cosine x dx. And if you're looking ahead, you might be seeing what's going to happen here. We've got e to the x sine x. It's kind of neat. Minus, and be careful with your signs because it's minus this whole next integration by parts piece. So r times t, negative e to the x cosine x, minus the integral of t dr, so it actually becomes plus the integral e to the x cosine x dx. So cleaning this up a little bit, we have e to the x sine x plus e to the x cosine x minus the integral e to the x cosine x dx. And if you've been paying attention, you're thinking, well, hold on a second. We started out with the integral of e to the x cosine x dx. And now we're right back to where we were. We did our integration of parts twice, and now the integral is exactly the same as what we had to start with. And that's actually kind of a good thing, because if I add it to both sides, now we have 2 times the integral e to the x cosine x dx, and that's going to equal e to the x sine x plus e to the x cosine x, and I can just divide both sides by 2, and we get that the antiderivative of e to the x cosine x dx is equal to 1/2 of e to the x sine x plus e to the x cosine x. So both of the, I want to go back to the top here. Both of these functions, e to the x and a trig function, sine and cosine, they're both kind of, they repeat themselves over and over. The derivative and antiderivative for e to the x is just e to the x, and sine and cosine just kind of flip-flop back and forth. These sorts of scenarios with functions such as this, we're going to end up with one of these scenarios like this, where we get that integral that we started with, and we can add it to the other side and then divide by 2. It's kind of a neat process, but it requires a little bit of thinking and observation about where it is we're trying to go, and actually what we started with is really important. So I'm not going to work this one out in all of its funness. However, I will give you the answer here. Let's see if you can get to this. This ends up being e to the 3x over 27 times 9x cubed minus 9x squared plus 6x minus 2 all all plus c. And I think in the last example I forgot to put my plus c. My apologies. Hopefully you're better than I am and you caught that. But see if you can't get to this answer. If you can't, let's talk to your teacher. Let's see where you might have gone wrong. I will tell you that it is necessary to use integration by parts not once, not twice, but 3 times. 3 times to get through this problem. And that is where I shall leave you. Good luck.